Welcome. In this video we're going to describe UML protocol state diagrams, or protocol state machines. You'll hear both terms. So what's a state diagram? Well, it's a diagram to describe the different states that an object can be in. What do we mean by that? So you can draw a state diagram for a particular class, or more generally in UML for a particular classifier. And what this does is it describes the qualitatively different states that an object of the class can be in. We'll see this as we go through. So, suppose that we say, when a new object of this class is created, so this is a start marker, the state that it goes into immediately after creation, we're going to call uninitialized. Okay, so at this point the object exists in the system, but it's not ready to do anything much for you yet. Okay. In order to get it to be ready to do whatever it is that it's supposed to do, this is a qualitatively different state, meaning your clients might need to know about it, or perhaps implementers of the class might need to know about it, but somebody might need to know about it. What we say is the object has to receive a message. Okay. Now, an object receiving a message is an event in the state diagram. So an event happens to the object, and in this case the event is that it receives a message in it. Okay, so the class has to contain an operation in it, okay, so that an object of the class will understand this message in it. And what this message does is it moves the object from the state uninitialized to the state ready. Now, what does that actually mean in terms of an object underneath? Well, it probably means that it changes the value of some attribute, or perhaps it changes the value of some link. You can think of these states as being abstractions of the fully detailed state space of the system. So it might be that you ended up saying, well, the object is uninitialized if, I don't know, the value of that attribute is null, say, because perhaps it hasn't been hooked up yet with another object that's going to let it do something. Okay, so once the object is in the state ready, we'll say it's ready to receive a message which we'll imaginatively call to do it, which is doing something that some client cares about. Okay, and when it receives the message do it, it returns to the ready state. Okay, and after some time, let's say, we're going to decide that we've had enough of this object. We're going to turn it off and move it into a defunct state. Okay. And let's just suppose that the message that does that is going to be called turn off. Oops. Right. Those brackets should really have been, I should have drawn that arrow longer. You see what I mean? And once it's defunct, let's say it's ready to be garbage collected or destroyed or whatever it is, depending on your programming language. And so we have here a stop marker to indicate that. Okay, so that's the protocol that you go through with objects of this class. So when you create a new object of this class, it's initially in this state called uninitialized. Then it receives an init message. Somebody sends it an init message. Some client sends it an init message, which takes it to the ready state. In the ready state, it can receive do it messages, however often somebody likes to send it a do it message, until somebody sends it the turn off message, at which point it moves into the defunct state, from whence it can't do anything else except be destroyed. Okay. Now, a protocol state machine is supposed to describe all the messages that an object can receive in any state, and so we have to ask ourselves, what happens if any of these messages are received in any of the states where we haven't described what happens? So, for example, what happens if, while the object is in the uninitialized state, it receives the do it message? Well, in this case it would be perfectly reasonable to say, well, that's not supposed to happen, and we will just not show it on the diagram. Okay, now there's a bit of a subtlety about this, but that's certainly a standard convention of how to use these diagrams, that if there is no arrow out of a state labelled with a particular message, that might mean that message should not be received when the object is in that state. Your implementation will have to do something. Maybe it raises an exception. What about if we receive the turn off message while we're in the uninitialized state? This is a design question, of course, but what you might say is actually in this case maybe that's surprising but reasonable, and we might in that case take the object skipping the ready state direct to the defunct state. And if that's what we decide to show, we can show that like this. Okay, so it's perfectly fine to have multiple arrows into the same state, even if they're labelled with the same message. What else do we want to say? We might want to say that neither the init message nor the doit message should be received when we're in the defunct state, so we won't show either of those. We've shown the turn off, we've shown the doit. We might want to say it might be the client's job to make sure that the init message is only sent once, and so again we might want to say it simply shouldn't happen that the init message is received in the ready state. And this gives us quite a neat diagram. We don't have to faff around showing error conditions and what have you. We're just showing the desired protocol for interacting with this object. Graphically, what do I want to say about this? These boxes, my writing's a bit messy here. What they're supposed to be is rectangles with rounded corners. Okay, that's how you show states in UML state diagrams. And notice the arrowheads, which are like that in state diagrams. That's a start marker. That indicates as I've said, the initial object, the initial state of an object when it's initially created. And that's a stop marker that says from which state the object can be collected. Those are optional, so it is useful to have a start marker because somebody might need to know, well, when I create an object, what state will it land in? But not all state diagrams have stop markers in them. And that's about all I want to say.